Good morning, student. Today we are starting with the fresh unit, ninth unit of 11th class, that is hydrogen. This is our lecture number 1. Question number 1 is discuss position of hydrogen in the periodic table. Hydrogen has one electron in its valence shell. In this capacity, it resembles to alkali metals. On the other hand, it also resembles to halogens because halogen need just one electron to complete their octet to acquire 8 electrons in their valence shell. Hydrogen being the lighter element, it is the element of first period. It also requires one electron to complete its duplet. So in this capacity, hydrogen resembles to both alkali metals as well as that of hydrogen. Now there was a problem how to place hydrogen, where to place hydrogen in the periodic table, and there was it was also seen that the hydrogen shows the properties similar to alkali metal as well as those of halogens. Therefore it was thought that it should be kept along with the alkali metals because alkali metals also have one electron in the valence s subshell and hydrogen also has one electron in the valence s subshell. That's why its position is in the first group, and that is in S block of the periodic table. This is although thought to be the peculiar or anomalous position of hydrogen, but there is no other alternative to keep hydrogen somewhere else, so it has been kept in the first group. This is our first question, that resemblance with both alkali metals as well as halogens, but on the basis of electronic configuration it has been kept along with alkali metals. Then we have question number 2, discuss resemblance of hydrogen with alkali metals. So now we'll discuss its resemblance with alkali metals as well as with halogens. So first of all we are taking resemblance with alkali metals. First point is electronic configuration. If we write the electronic configuration of all the members of first group, that is Halinath Rabkasper, Halinath Rabkasper. Hydrogen is having atomic number 1, lithium 3, sodium 11, 19, 37, 55, 87. If we see the configuration, it is 1s1, then we have helium core, 2s1, then we have neon core, 3s1, argon, 4s1, krypton 36, that is 5s1, then xenon 54, 6s1, then we have radon 86, that is 7s1. So all the alkali metals, general electronic configuration, that is ns1. So this shows a resemblance of hydrogen with alkali metal, since all of these elements they have one electron in the valence shell. So this shows the resemblance of hydrogen with alkali metal. Second is electropositive character. Just like alkali metals, alkali metals, hydrogen has a capacity to release one electron and form unipositive ion. Sodium, when given first ionization energy, it will form Na positive plus electron. Potassium given first ionization energy, it will form K positive and electron is released. So this characteristic of alkali metals and hydrogen resembles mutually because both of them they are capable of releasing one electron by absorbing small amount of energy. Then we have action of nonmetals. Just like alkali metal, they are electropositive metal. Hydrogen can also behave as electropositive metal. Alkali metal combine with the non-metals to give salt-like compounds. H2 combines with Cl2, it also forms salt-like compound. Then we have fourth, electrolysis of these compounds, salt-like compound will yield hydrogen at cathode. Just like alkali metals, 2Na is obtained at cathode, Cl2 at anode, similarly H2 at cathode, Cl2 at anode. So these two, they are obtained at cathode and this is obtained at anode. It also shows the resemblance of hydrogen just like alkali metal where hydrogen is liberated at the cathode during electrolysis. Then we have the ionization enthalpy, that is our fifth property, ionization enthalpy. So hydrogen has high ionization enthalpy as compared to alkali metals, and it will have to lose one electron but require more energy, but it can lose that electron, that's why it resembles to your alkali metals. Then we have the reducing character. Just like alkali metals, hydrogen behave as a reducing agent. It can reduce some of the metal oxides into their metal state. Cu is produced during this reaction, similar to alkali metal. They can also combine with the cuprous oxide to give you Na2O plus 2Cu. So it behaves as a good reducing agent, just like the alkali metal. So all these properties, they are showing resemblance of hydrogen with alkali metals. Now we come to the next question, resemblance of hydrogen with your halogens. So this will be our third question of lecture 1 from hydrogen chapter. So discuss the resemblance of hydrogen with alkali metals. Discuss resemblance of hydrogen with halogens. So we'll be discussing on the same pattern. First of all, electronic configuration. If we study the electronic configuration of halogens and hydrogen, all of them, they require one electron to acquire the electronic configuration of next noble gas. For example, we have hydrogen configuration is 1s1, we have fluorine configuration is 2p, you will be having 1s2, 2s2, 2p5, 2px2, 2py2, 2pz1. So fluorine is having atomic number 9. Similarly, chlorine, it will be having the configuration that it will be 3pz1. Then we have bromine, it will be having 4pz1. Then we have, after this, we have the iodine, 5pz1. Astatine, 6pz1. So in this manner, all of these elements, they require just one electron to acquire noble gas configuration. If they are getting one electron each, then we get hydrogen, we get chloride, we get chloride, we get bromide, we get iodide, and this is electropositive metal. We are not supplying electron to it. So just like hydrogen, just like halogens, hydrogen is capable of forming electronegative ion by accepting one electron. So this characteristic will show the electronegative character of hydrogen. So just like halogen, hydrogen is capable of accepting one electron and it serves as a electronegative element. Then we come to the reaction with metals. just like halogens, it can combine with metals to give salt-like compound here. So reaction with non-metal is X2 reacts with non-metal. For example, we have H2 plus sodium metal. On heating, it will give sodium hydride. Here, hydrogen acquires negative charge when reacts with metal. It behaves as an electronegative element. Similarly, Cl2 can combine with 2Na to give you 2NaCl. So these are salt-like compounds when they are electrolyzed. Electrolysis of these compounds, salt-like compound, liberates hydrogen and halogen at anode, which shows its electronegative behavior. You will get 2Na plus hydrogen at anode. In this case also 2Na at cathode and Cl2 at anode. So this property establishes the electronegative nature of the hydrogen. Then we have the next property, that is existence. So they both exist as a diatomic gases. All halogens exist as diatomic gases, F2Cl2 Br2. Just like hydrogen, hydrogen also exists as a diatomic gas. Then we have the oxidation state, just like halogens. Hydrogen shows -1 state. It is -1 like halogens. They also show -1 oxidation state. Then we have oxidizing character. Like halogen, hydrogen is also capable of accepting electron. Therefore, it behaves as a good oxidizing agent, not as good as the halogens, but it behaves. H2 can take up 2 electrons from metals and can form hydride ion, similar to Cl2 take up 2 electrons forming chloride ion. F2 can take up 2 electrons to give you 2F negative ion. So in this manner, halogen and hydrogen, they resemble to each other. Then we have non-metallic character. Like halogen, hydrogen exists as a non-metallic element. Nature of its compound, just like halogen, hydrogen is capable of forming the covalent compounds. Its property is nature of compounds. Covalent compounds like halogen. CH4, CCl4, they are similar compound. SiH4, SiCl4, they are all covalent compounds. So this shows the resemblance of hydrogen with the halogens. So after discussing this question, now we see some point of difference of hydrogen from alkali metals as well as those of halogens. So our next question, question number 4 will be, how do hydrogen differs from alkali metals? How do hydrogen differ from alkali metals? Number 1 is small size. The sizes of alkali metals, they are quite large, they are largest in their groups, but size of hydrogen is very small as compared to alkali metals. Second, oxides of alkali metal, are acidic, but oxide of hydrogen, that is water, is neutral. So oxide of water, it is neutral in nature. Then we come to the third property. The ionization energy of alkali metal is low. While that of hydrogen is high. Hydrogen is less reducing agent as compared to alkali metals. Which are good reducing agent. Then bond energy of sodium, hydrogen forms diatomic molecules. Alkali metals do not. Hydrogen is highly inflammable. Alkali metals are not. So these are the differences of hydrogen from the alkali metals. Then we have the differences of hydrogen. How do hydrogen differ from halogens? Small size, halogens have large sizes, it has small size because it has only one shell. So size is small, nuclear charge is less in this case. Second, it is weak oxidizing agent as compared to halogens, which are strong oxidizing agents because they can easily accept electrons. Hydrogen cannot accept electrons so easily. Then in the atomic state, hydrogen has no lone pair of electrons. In the molecular state, hydrogen has no lone pair of electrons. Halogens have lone pair. Halogens have 3 lone pairs. Each halogen. It does not have so much. Hydrogen is combustible. Used as fuel. Halogens are not. They are neither combustible nor they are used as fuels. Discuss occurrence of hydrogen in the atmosphere. How do hydrogen occur in atmosphere? Number one, hydrogen is existing as a gas in the atmosphere. It is found in sun, stars and all planets. In earth crust, it is found to be 0.9% by weight, and in the combined state, it is found in the water and sea, petroleum, animal and vegetable matter. All matter they contain hydrogen. It is a very important element of the organic chemistry. What is the ABC of chemistry? That is carbon, hydrogen, oxygen, where hydrogen is the most important member element of the family. So this is, you can say that hydrogen is highly important from our life point of view. Then discuss isotopes of hydrogen. Answer: it has 3 isotopes. They are 1H1. This is called as protium. 1H2, deuterium. 1H3, tritium. So hydrogen, it exists in the 3 states: protium, deuterium and tritium. It has 3 isotopes. All of them, they are important and they serve as important elements of the number of compounds. So this is our first lecture.